Okay, so we've talked a little bit about acids and bases in the course of the course. You guys looked at the crash course video and you found out a little bit about acids and bases. From the crash course video, what do you remember about acids and bases? Acids are sour like lemons.
Acids like no bases except the proton.
Yep, bases accept the protons.
And then the acids will give it.
Right. So if you go to the first slide, that says basically that acids donate the hydrogen ion, and it's an ion because it has a positive charge. So, and bases accept the hydrogen ion. When they combine, then you get HOH, which is water. So they neutralize into water. So if they're strong, that means they come apart easily in water. So like stomach acid, which is actually hydrochloric acid, nitric acid, battery acid, they donate the hydrogen ions easily. They want to give them up, which is one reason they're so caustic on your hands, or skin. They'll donate the hydrogen ions to your skin and they kind of eat it apart. Strong bases accept hydrogen ions easily. So sodium hydroxide is a drain cleaner, bleach, and ammonia. So a lot of the bases are cleaners, okay? And acids are used to like strip stuff. So like pop is an acid. So it will eventually, if you eat enough of it, strip the enamel off your teeth. If they're weak, they don't come apart or dissociate easily in water. So things like vinegar, orange juice, vitamin C, aspirin, they don't come apart easily. They're a little more complicated in structure. Weak bases, same thing. They don't accept ions as easily. So you can use them for things. So a weak base a lot of times is a soap or an antacid that combines with the acid. Okay, so obviously the plus charge from the hydrogen ion and the negative charge from the hydroxide ions attract each other, and when you combine them, you get a neutral charge. We're just going to talk a little bit about pH in general. Like we said before, the more hydrogen ions they are, the lower the pH, the stronger the acid. Okay, so a low pH means a strong acid, lots of hydrogen ions. That's an inverse relationship. The more hydroxide ions there are, the stronger the base. The stronger the base, the higher the pH. And so there again, we have that pH scale of 1 to 14. And the reason we need to know this is the use of pH and acid theory is really prevalent in the cheese making industry. We just made an acid coagulated cheese. They use starter cultures to ferment the lactic or to metabolize the lactose into lactic acid for harder cheeses like cheddar. And yogurt cultures also produce acid. The production of the acid affects the quality, the characteristics, and the flavor of the cheese. So if there's too much acid production, the cheese might not form correctly. It might get holy. The bacteria might actually produce gas. There might get holes in it that they don't want if you're using bacteria for acid. If you have too much on a soft cheese, it's going to taste acidic and not taste good. And that's the end of that lecture. Hold on.